So this is Mod3 Sums, small 6x6, which is quite challenging indeed. So for the rules, every row column in 2x3 must contain all the digits from 1 to 6. Then we have modular lines in blue here. So any sequence of 3 successive cells along the line must contain one of each residue of each Mod3 modularity. So in other words, one would have to be from 1 4, the other 2 5, and the third 1 3 6. The other doesn't matter. These two lines, these two cells, well, can't include all 3 of course, but must have different residue sets. And we have an additional constraint, is that the sum for all the lines, there are only 2 available at most 2 different sum. So this, for instance, this cannot be 15 and 9 and then 12 or something like this. So there's only 2 sum. Then we have a black dot, so these two are in a 1 to 2 ratio, or one is the double of the other, and the white dot, these 2 digits are consecutive. So that's for the rules. Now all line of 3 or line segment of 3 sum to a multiple of 3. This is because of the nature of Mod3 modularity. So I can explain this the easy way. If it were 1 2 3, this is the minimum. This would contain all 3 modularities, and it puts them to 6, and then we can replace the 1 with 4, so this at 3, multiple of 2. We can replace 2 with 5 and 3 with 6, and every time it's an increment of 3. So this is always the sum here is always a multiple of 3, and this is true for instance 3 even for 4 line segment. These 3, the sum is multiple of 3, and these 3 and these 3, for instance, and these 3. So if we can start here with the easy one. So this is a multiple of 3, and the black dot itself is a multiple of 3. So one digit is double of the other, so their sum is 3 times the smallest digit. So in order to get 21, this must be also a multiple of 3. The other ways to notice there must be a 3 or 6 here, so the dot, black dot can't be 3 6. I will make it this way. So it's 1 2 or 4, I must include a 2, and so there is 1 but only 1 3 6 here, and the other one goes here. So no, this line can't include a 2, so it must include a 5, because it must contain one of 2 or 5. And now the question is, well, we know these are always multiple of 3, and the question is, the idea is that could this line not be a multiple of 3, so be something else. So here the easy way, well, easy, So this is a multiple of 3, 21 also. Oh, it must contain one of each here, modularity. So it must contain one of each modularity here. So this is a multiple of 3, and this line segment is also a multiple of 3. So together, this is a multiple of 3. Indeed, probably a multiple of 6. So minimum here is 1, 2, 3, 4, which is 10, and then 1, 2, which is 3. But we know it's a multiple of 3, so the sum, so it can't be 10 and 3, which is 13, so the minimum is 15 here. But no, because both these 3 cells are summed to a multiple of 3. But no, if one of these is not a multiple of 3, the other is not either. Because if it were, let's say, 5, 6 here, so 11, this would not be 5 or 6, so multiple of 3 plus something which is not a 3 or 6 would also not be a multiple of 3, and because we have only 2 sums available, these 2 would have to sum to the same total, which is a real problem. Because then they would have to sum to 18, and both would have to indeed they were the same total, so the sum of 2 times this the sum of 2 times this total would be an even number, so it couldn't be 15 but 18, and this would make it divided by 2 is 9, so whichever the case, these 2 are also a multiple of 3. So this is 3, 6. Now we can check here. We know I will highlight everything which is not 3, 6 in light green, for instance, so we can chase the colors, the 3 6s. Now we can check for this one. If it were not a 3 6, all the other lines would have to sum, which are multiple of 3, would have to sum to the same total. So all these would have to sum to the same total. And so if it were not 3 or 6 here, multiple of 3 here, this would be the only other sum, possible sum for the whole puzzle. And then this total, so these 2 would have the same sum, placing a 3 here. The maximum here is 4, 5, which is 9. They would have at most sum to 9. 6, I think, is not an option. While 3 and 3, this is the minimum here. So this is already 6, so they would all have to sum to 9. Having 3, 3, 1, 2, 4, 5, and 6. But the idea is that because of this white black dot, this cannot be sum to 9, I think. And this is not the easy part. Well, I can write it down, so maybe it's easier for us to check. This would be 3, 1, 2, 4, 5, and then 1, 2, 6, and then well, this would not contain a 3, so it would contain a 6, and it would have to be 1, 2, 6. But this is a problem because you have only 3-digit available for cell. So indeed, this also must be a multiple of 3. These are 3 6s. And now we can continue with the 3 6 pairs. So this is 3 6. This is not. So here, this line must contain 3 or 6. So if it goes here, this is all the 3 6s for the line, and it would go here for this line. So if it goes here, the 3 6 would go for this line, would not go here, but here. So there's always a 3 or 6 over here. So these two cannot be 3 6. It's kind of X-wing. So the black dot cannot be 3 6. And so this is indeed. So there's a 3 or 6 here. So that's all the 3 6s for the column. Here there is a 3 6. That's the only place it can go in the column. So now we may count the 3 6s. This is one column, one column, and then let's make it black, this one, and this is a red one, the other one. So the black here for this box goes indeed here. So this is the red one. The black for this box goes here. this is another 3 6, the red one. So the red one goes here. This not a 3 6, so it goes here for this line, and this is the black one. And so it's missing here a 3, the red 3 6. So these are all the 3 6s. We can get rid of this gray color. So no, this is not a 3 6, so it's also 1 2 or 2 4, always contain a 2. And so here this is one modularity because of the black dot will be 1. If it were 1 it would be 2, if it were 4 it would be 2, and if it were 2 it would be 1 4. So these are for different modularities, and because of the line these also are different modularities, so these are the same. Well, let's say if it were green, purple, this one for instance, this would both be the other modularity. So we can continue this. We have only 2 available. This purple in there, so this is green. The black dot, well, it can't be the same modularity, so there's a purple there, this is green. There is green in there. Oh, this is the same as. So this is purple, this is green, and this is for the row. This is green, purple. So we have purple in there and a green, so this is green, purple. For the column this is green, no, this is purple for this column. And what else do we have? So we have a pair here, a pair here, a pair, a pair. And maybe we can change the. I like these, so let's start with this black dot. So this would be a black flash. So these are red flash. So these are black. Red, black, and black, red. So this one sees both flashes of red and black, so this is green. This is purple and it's not black, so it's red. This is purple red for this column, so this is green. And so now here we have a 2 in the black pair because of this black dot, so the 5 goes in the red. So for instance there is a 5 here, because this is 1, 2, 4, maybe I can mark it down. Well, indeed, here the purple black flash goes in there and in there. So the 2 goes on one of the black flash, so the 5 goes in one of the red flash. Well, we don't know for the green here, but so this is either 1 4 or 5. It can't be a 2 because it is this one. So this can't be a 2. Now for the white dot, 1 gives 2, 4 can give 3, so it would give 5, and 5 can be 6, so it could be 4. Now this one here from this box goes there and goes here. So there's no 5 in there. So 4, well, can't be 3 nor 5, so there's no 4 in there. So the purple red is can't include the 4. So 1 5. And so this is 2 4, which goes there, which goes, well, we don't know for the rest. And this is the same modularity as this one, so it can't be the same value. So if this were 2 5, this would be 5, or if it were 1 4, this would be 1, or 1 5. There's no 1 here, so this is 1 or 5. So 1 5 pair. There is no 1 in this. And no, here we have the different flash color for the 3 6. So this is indeed a pair. So the sum is 9, and we have a 2 4, so it's 6. 9 and 6 is 15, and well, these 2, which is also, so all 9 are multiple of 3, so this can't be 15. The maximum is 4 5, which is 9. Now the pair that goes here is the green with a red flash, and the purple with a black flash. So the green with a red flash, the purple with a black flash. So these 2 are the same, and they can't be the same total, because we have a 3 or 6. This is either 3 or 6 more. So this is the smaller and this is the larger one. So this can't be the same sum here. So this is 15. So this one must also be 15. Can't be a third total because of this. So 15, this is indeed 4, 6 and 5. That's 6, and then just a question of finishing the puzzle indeed. So these red flash are 6, the black one are 3, the purple is 1, 4, purple are 1, 4, and so 1, here we have a 2, and the green are 2, 5, so 1, 4, 2, 5, so 5, 2, 2, 2, so I will put in the colors here. 5, 2, and 4, and so that's it. We have one sum which is 15 here and here, and the other sum is 9. So this is 6 and 3, 9, and 3 times 3 is 9, so 15. And then we have here we have 6 and 3, 9, which is the same indeed as this one. So I know it's kind of tricky, but once you decide, you find that each of the line are a multiple of 3, make it easier, and this way that makes a difference.